Hi, hello everyone. Welcome to this latest edition of the Aerospace Testing webinar series. My name's Tom Stone. I'm Editorial Director of Aerospace Testing International magazine. And today's webinar is with Telspan Data, who you may well know is one of the industry's leaders in ground-based and ruggedized telemetry systems. So they design and build products to the latest standards and technologies that are used by the operational and test communities in aerospace and defense. So today with us, we have Telspan's Chris Lloyd, who has over 20 years systems level experience. And he's going to talk us through some of the company's range of recorders, switches, gateways, and TAPs, along with ground systems and its data fusion software. So I'll hand over to Chris in a second. He'll give his presentation, and then he'll be available to answer any technical questions you might have. So you'll see on your screen, you should see a box for entering your questions. Please feel free to submit them as and when they occur to you. They won't appear on the screen. They won't be published to the rest of the attendees until we get the chance to answer them. And if we don't manage to get through all the questions, Chris will be able to get back to you with answers after the event. So I think that covers all the housekeeping. It's great to see so many people here and logged in. So I will hand over now to Chris to begin his presentation. Chris.
Thanks, Tom. I appreciate it. As Tom said, I'm Chris Lloyd with Telspan. Hope everyone's well today, and thank you for coming. As Tom mentioned briefly, Telspan, we support with hardware and software the aerospace and defense testing space, if you will. And with that, we design and manufacture, of course, recorders, data recorders, switches, gateways, taps, ground systems, and data fusion software. These typically fit into kind of four key areas of aerospace and defense. Of course, airborne. A lot of our experience and history is in instrumentation for airborne applications. We've recently started getting into some ground test applications, providing time-sensitive network switches and such to Army test programs. Of course, shipboard and the range and lab, and that's where we're going to focus most of our conversation today. That said, a ruggedized, kind of give you a brief introduction to that. Essentially with our ruggedized application, we fit in many places, of course, but our main purpose is to aggregate, tap, switch, route, filter, record, process, and of course provide links to be able to telemeter that type of information to the ground. Data sources can include just about anything with a wire, but data acquisition units, cameras, avionics, radars, pods, you name it. Our hardware can connect to it and route that around. Our primary focus of today is to talk about telemetry ground systems. So what is a telemetry ground system? I'm showing you a couple of integrated systems that we've done. Which is kind of neat because with technology today, everything's getting smaller and faster, of course. We're able to, in very little space, build an entire telemetry ground system. So what we're seeing here is some 1U telemetry receivers, and of course our products there, what we call the DataHUB, which we'll describe in detail later. An embedded computer, and hook this up to an antenna, and you've got a extremely powerful telemetry ground system that used to perhaps fit in a trailer or even larger laboratories and this kind of thing. So let's dive in a little bit. Where does Telspan fit in this ground telemetry environment here? Essentially, we're everything after the telemetry receiver. So you'll have a clock and data output from your TM receiver, and that will come into the DataHUB product line, where we can then process that data. And by processing, we can record, convert, and publish data directly from the box. So at a very high level, that's kind of where we fit into these ground systems. So let's describe these a bit more in detail. We currently offer 3 different packages of these DataHUB products. You see on the top one there, that's what we call our portable one. The middle one is a 1U, and the bottom one is a forthcoming 2U version of the product. Because these all share the same main board, the same processing PC board, they all share many of the same features and capabilities. So diving into what some of those are, PCM. So essentially we're bringing in PCM channels, depending on the channel count based on the size of the enclosure. These are bidirectional, meaning they can be an input or an output, and that's a software selectable feature. And they can bring in speeds up to 50 megabits per second per channel. So if it's a 4-channel box, you can bring in 4 streams at 50 megabits per stream, so on and so on. Each of these have an Ethernet, at least one or many Ethernet SFPs. SFPs allows you to plug into whatever you might have on your network, copper or fiber. And these are used to publish data. They're used as gateway functionality, and they can be output to external telemetry recorders, or they can be used to reproduce data. Each of the DataHUB products has removable media for recording the data. We'll describe those in a little bit of detail on how they differ for products. We include a GPS receiver on every one of these, and that can be used to seed the internal clocks. And these internal clocks can be ARINC A, B, or G with DC or AM inputs and outputs, NTP, IEEE 1588, 1 PPS, you name it. DataHUBs can work in just about any timing environment. We include UART channels, analog channels, so maybe recording audio or something like that, and a video channel, which can be used maybe in a flight line type of application. Programming the DataHUB is very straightforward and flexible. Most commonly, people would use a web GUI interface to do that. So, web browser, type in the IP address of the DataHUB, and you get a complete command and control GUI for that. It can be done through a command line interface, and it can be programmed to respond to discrete input capabilities. One of the things we like most about the DataHUB is it's FPGA based and a Linux based system. What that means is there's no Windows operating system at any part of the hardware level. So all of the data processing, the gateway functionality, recording or converting PCM and aggregating data and so on is all done in the processor. So there's no need to go through secondary processing. So PCM in, record chapter 10, publish chapter 10, publish other types of data streams. All that is done in a processor. It also makes it flexible for future upgrades as things change, makes it easy to have a new firmware load and provide new functionality to a in-place system. And all of the DataHUBs work as recorders, publishers, subscribers, and reproducers, and that means lots of different things. But basically, it gives you flexibility to process the data the way the environment does, and gives you some growth patterns to do different things. So some of the what we call multidiscipline features of the DataHUB. I mentioned it's a recorder or a publisher. What does that mean to the end user? Let's say you're at a flight line and you've got a PCM stream coming in. The DataHUB products can record that data internally on the storage provided. They can also publish that data, and they can do both at the same time, of course. but you might have a case where you've got the DataHUB product connected to a laptop, you're recording in the DataHUB, and then you're able to real-time look at what's in that PCM stream. So it gives some flexibility beyond just a standalone recorder. And a reproducer. So maybe you've recorded chapter 10 files, and those are encrypted, and you need to run those out through a decryption unit, or you simply want to take and replay your recorded files out as PCM. Because the data hubs have inputs or outputs, allows you to take a recorded data file, play it back, and output it through that PCM. If you're in an encrypted environment, perhaps that output goes through a decryptor, and then you can bring it back in through the DataHUB and record it as unencrypted. So the reproducing capabilities gives you a lot of option for perhaps post-processing or handling of your data. Everybody's speaking of gateway functionalities, and that can mean lots of different things to different people. But basically what we're saying is the DataHUB can act as this kind of a middleware between different data standards. Lots of different things to go in there. We can give probably an entire presentation specifically about gateways. But at the simplest terms, you can have PCM streams coming into the DataHUB and output them as Ethernet. Maybe you have Ethernet coming in and you want to put those back out as PCM. We're seeing a lot of application where we're going to have the ARINC 106 Chapter 7 standard applied here. And that might mean that you've got something encoded as Chapter 7. It's a PCM stream coming down, and then the DataHUB can decode that Chapter 7 formatted PCM stream and put it back out as Ethernet. So tons of capability here in gateway functionality. And again, because it's FPGA based, as standards grow and change and new standards come around, these can be supported and added to the DataHUB. So gives you growth potential and long-term support for the product. And depending on telemetry receivers, some of the new ones are coming out with the Chapter 2, ARINC 106 Chapter 2 DQM, DQE standard. The DataHUB can support that. We're kind of in the final stages of development on that capability. And what does that mean for the user? Let's say you've got 3 or 4 different antenna sites, and the data is coming through the receivers, and of course it has this DQM data quality metric number. The inputs from those receivers, or excuse me, the outputs from those receivers can be input to the DataHUB product, and we can record those as truth data, and the best source capability built into the DataHUB can create a virtual channel from the best source, essentially. And so that best source can be also recorded and published. So perhaps you've got your 3 telemetry sites. They're receiving their data, we're recording that, but the quality of flight people want to look at best source, so that can be published to them and they can display that in their software, or our software we'll talk about here in a little bit. So really trying to add lots of functionality and capability into a product that used to just be a standalone PCM recorder. So adding quite a bit there. So the different models, like I mentioned, they're all using the same internal components, but because of form factor, environment, will expose different amounts of capabilities. So in the portable unit, this can support up to 4 streams, bidirectional 50 megabits, and it allows them to be TTL or 422 inputs. It has a single Ethernet SFP for the publishing gateway functionalities, or record and reproduce. There's a removable CFast drive behind exposed behind a door on the other side of the unit we're not seeing here. It can still bring in analogs, videos, has the same GPS and ARINC capabilities. So in a very small package, you can get quite a bit of capability. It is environmentally sealed. We've seen applications where they want to put these in the base of a telemetry antenna and different fieldable type applications. The NetView Data Hub, again, all those same features. The main difference here is we have 8 PCM streams. These are only TTL, mostly because of the physical space for connectors on the back. And this will have 3 independent Ethernet SFPs. So that would perhaps allow a user to create channel groups of the 8 inputs. For example, you could make a channel group that has, say, 4 PCM streams with it, and that can record to one drive and be published out one of these Ethernet SFPs. And you can have another channel group publishing different channels out of the different Ethernet. So that allows you to put certain data onto certain networks and so on and so forth. Recording in this is, there's 2 NVMe style hard drives. Currently, they're up to 16 gigabytes, terabytes in size. And because, again, of channel groups, we can record data to one or the other drive. We can perhaps duplicate data and record data, the same data, to both drives. Really flexible in how the data is recorded or produced. Forthcoming here, we're in the final mechanical design. We have a 2U version of the DataHUB. This one is really specifically purposed for larger test sites. It can support 24 TTL and 24 422 inputs, but basically it's the same as the 1U. We just have an expansion module that sits on top of the main processing board and allows you to expand that PCM channel count. So we really spoke a bit about hardware, but you know, the DataHUB can live in a couple of environments here. So a lot of facilities might have their own homegrown software application or something that they've been using for a lot of years and don't want to change all of that. So in this scenario here, we're showing basically the output from the TM receivers coming into the DataHUB. And with the 3 Ethernets publishing data out, we're doing Chapter 10 publishing, Chapter 7 gateway functionality, or perhaps broadcasting, publishing the DQM, DQE best source. That can, of course, go to any software, but we're finding a lot of users appreciate the flexibility and capability of our NetView software, which we'll talk about here next. So NetView can operate in lots of different scenarios here. We've seen it used in pre-flight scenarios. A user might walk out to a flight line or some sort of production facility where they need to test kind of in a pre-flight scenario. They can connect up with the DataHUB, or perhaps they already have a product that can publish a stream. Of course, a real-time environment, so a DataHUB or another publisher is on the network. We can display data in real time. And then with some of the analysis capabilities, if you will, built into NetView, we can certainly live in some post-test environments. So at its core, NetView is a subscriber to a Chapter 10 publisher. What that means is it can connect to a network or a publisher on a network and bring in that Chapter 10 or PCAP or ARDS type of data files, Chapter 7 and so on. It can also act as a publisher, and what we get our meaning by that is we could be subscribing to a Chapter 10 publishing source, and we can turn around and republish that perhaps to multiple other NetView workstations or other recorders and so on and so forth. NetView can also record the data and replay data in its existing from pre-recorded data files, of course. We can decode all the different Chapter 10 data types. We've got lots of different data display capabilities, raw data. That could be looking at Ethernet data packets, 1553 data buses, all these different possible sources, really getting at the granular look at the data. Current values, so these are scopes and FFTs and so on. Time history, maybe line graphs and so on. We support 2D and 3D flight type displays, dynamic imagery, show videos, audios, and it's very easy to manage because of what we call the docking display framework. So in real time, the user can add, change, move, update displays, and move them around within one or many monitors and dock those in there. So you get a very organized, clean environment to visualize the data. And a unique thing with NetView is its ability to support multiple Chapter 10 files in a playback scenario, or support multiple streams in a subscriber scenario. So it will time align these multiple streams, and you can literally display a measurement from one stream against a measurement from another stream in the very same channel. Or, excuse me, very same display. Some kind of more advanced capabilities, full export capabilities. So you can take and zoom in on specific data and export it to an Excel or something along those lines. You can do exports of complete data files. It has a math engine, so you can create derived parameters. It can automatically set itself up from the TMATS setup records. So that makes initial turn on of a new telemetry stream quite straightforward for the end user. And it's a full 64-bit software package now. We still support a 32-bit for older scenarios, but full 64-bit support. And realizing the environment we work in, there might be special decoding requirements for customers might have for their specific test or data streams and such. So we've provided a full SDK, software developer kit, that lets users get at the source of data, so they can build a custom decoding should that be necessary for their environment. So a little bit about an application that's perhaps a bit different than a typical telemetry environment, but we were tasked by a large aerospace customer to come up with a means for a large scale static and fatigue test. And because of the flexibility and power of NetView, we were able to aggregate lots and lots and lots of data by taking the proprietary data streams from a bunch of different sources and converting them to Chapter 10. So a load control system, in this case from Moog, a traditional strain gauge system from Pacific Instruments, a fiber optic strain sensing system from Sensoron, and a digital image correlation from Correlated Systems. So we took each of those proprietary data streams, convert them to Chapter 10, and then create individual Chapter 10 publishers for those. Of course, we time synchronize all of those. But what this meant was more than 60,000 discrete channels from multiple data sources are now coming in and being aggregated against NetView, or excuse me, aggregated inside of NetView. NetView then can dump that down for data recording. And then it also turns around and publishes that data out to, at this point, more than 30 analyst workstations. So we've kind of got it in a client server configuration where data is being ingested by one machine, recorded, and published out for the individual analysts to look at data any way they want. And one of the main advantages of this is before something like this was available, the analysts would have to use a different GUI from a different manufacturer to look at the specific data being produced by that system. And as technologies are changing, for example, the fiber optic strain system, you might have a fiber running down the length of a wing, and then you have a whole bunch of traditional strain gauges glued down there. There was no way to visualize a comparison between those strain gauges and that fiber system. But since NetView is basically aggregating data from those systems in a common standard, it allows the user an ability to plot a specific channel from either system on the very same display. So in the end, that really limits the amount of training the users have to go through, gives them a new capability, and so on how to visualize the data. Part of this was, now we've got all this recorded data, what do we do with it? So we developed an add-on to NetView called QuickView. And what this allowed is the user to quickly plot data. I'll show you a screenshot of that. So across the topmost, we basically opened a chapter 10 recorded data file, and it shows us a complete time history. And then we can zoom in and out of specific sections of that time history and put it onto line graphs and XY plots and so on. And a lot of times, users in a scenario like this are really interested in the data at various endpoints of testing. So they might continuously record for hours and hours, but have multiple endpoints. So we give the analysts an ability to plot that data at various endpoints and zoom in and analyze that, and maybe it's a go, no-go scenario or part of a report that they have to generate. But by the time you zoom into that data, you can then export a time slice of that and get that into different things the analyst might have to do. So that's a whole lot of information in about 30 minutes. I'm going to quickly share my screen and show you kind of NetView in action, but then perhaps we can open up for Q&A. Give me one moment here. So quickly, what we're looking at is a NetView playback. What we have here is two separate recorded data files. These are from, in the case of this, two different jets. Of course, time synchronous data, so we're playing that back in real time here. Through a bar chart here, excuse me, a time chart on the top, I can quickly move back and forth between data. Individual displays, I can zoom in and out of different channels and see different things. I can switch between different video sources. I can look at this. I can move things around and dock and undock and so many different things. But the idea behind NetView is to really make it easy to visualize the data in any specific way you might need to. And realizing that things change during test, or especially in a post-test scenario, the user can very easily add different parameters to existing displays, remove parameters, and so on. The NetView Manager gives us an ability to look at a lot more of the perhaps data associated with different channels. This might be information from your TMATS and so on. I could probably do an hour plus long presentation of just of NetView, but I just wanted to make sure you were able to get a quick look at that. NetView is available in different packages and available for trials and so on. So I think my time is just about done for presentation. So let's review. I think I lost my slide deck. There we go. Let's review some perhaps questions you might have.
Thanks very much, Chris. That was great. Very interesting. I love the visual display at the end there. It was like almost like being in the plane.
I hope so.
It was great. It was very, very impressive. And I guess, we've got one or two questions coming in. Do feel free to drop those questions into the Q&A box. But I'll just start with a couple of general questions, if I may.
Sure.
I suppose, there's a few different challenges that you spoke about there. But what do you think is the largest technical challenge that you face or that has been recently overcome with telemetry? What's the big one?
Probably lots of big ones. I think it's a few things going on. There's a push for modernization. There's a push for different standards of how the data is shown and processed. And while we very much back the Chapter 10 standard right now, we very much develop our products to be multidisciplined, and that's a phrase we use quite often because it's important to be able to support whatever the customer might be doing. So I'd say one of the biggest challenges is developing products that can work in a number of different environments against a number of different data standards, and of course make all that user-friendly and capable for the customer. So that's certainly one of the things that we spend a good deal of time trying to support, design, and develop for.
Absolutely. And you were saying a little bit at the start there about making things smaller and some of this ground-based stuff that you've got to fit into tight spaces. Is it getting smaller and smaller? Do you see this sort of, they're quite big, chunky boxes, some of them, but is that going to, are we getting smaller and smaller as we go into the future with this?
I'd say I'd be surprised to see it get much smaller, but I guess the idea behind this is the capabilities there now to do it, and what would have literally taken 40 U of rack space, we can now do in 2 to 4 U's. So you get much smaller than that, connections become an issue, and lots of cabling infrastructure. But we're happy to see the amount of capability we can put into any of our products because of FPGAs and smart design. So this feels like it, but ask me again in 5 years from now.
You never know, do you? You still got to be. Yeah. Well, at the moment, we've still got to pretty much always plug an Ethernet cable into it, right?
Yeah, Ethernet. Yeah, cable is the problem, I think.
Yeah. Maybe one day we'll do away with that, but until that day, we're probably about where we are, so to speak. But just moving on to some of the questions that are coming in, and leading on from that, really, Matthew Enquist has asked about the ruggedization, particularly how rugged is the 6005 and 6010? Fieldable raw or needs to be in an enclosure?
That's a good question. Fieldable raw is probably appropriate for the 6010. I think you saw them here in these ruggedized cases. These are shock mounted cases, but really nothing special. The one here on the left, an aluminum style, and the other one, composite type, injection molded type of thing. But they have some shock mounting in there, but there's front and rear mounting available on most of the hardware that will go in these. So once we do that, they're shipped by FedEx and moved out of trucks and everything like that. So fairly rugged. The portable unit, the 6005, we were mentioning earlier here. That's this product. Is because of its design, it's really designed similarly to our ruggedized boxes. At this point, we haven't done any mil-spec testing on it, but it is possible to do conformal coding and everything on the circuit boards inside. So this one ultimately could become quite a bit more rugged than the 1U box. We did mention it is environmentally sealed. So there's some cooling in the bottom of this where we can move air across the bottom of the box without bringing air into the box. So this one has the capability to become somewhat more ruggedized.
Cool. Excellent. Moving swiftly on, questions coming in now. Greg Buffalo's asked, what is the current delivery on a 4-channel?
Thanks for asking that, Greg. We're just about to start delivering the first production of those. We had some mechanical issues, if you will, but just about ready to make those available to market.
Excellent. We've got quite a long question here from Lo. Several parts to this, so I'll see if I can pull this by. Can you see that there on your screen as well, Chris? I'll just read it out. In a Chapter 7 TM stream with multiple PCM, Ethernet, ARINC,
yeah, ARINC,
3, etc. data types, how do you handle time sync / RT counter alignment?
You know, this is where I wish Mark Buckley was on. I don't have the pedigree he has for this type of information. That might be a better question. If you wouldn't mind, we can get back to you aside from this platform.
Okay, yeah. Well, we will definitely be able to get back to everyone with questions afterwards. So we'll pass that on to him, no doubt. And what role? Then leading on, there's a couple of elements to this question. What role does the ground system play in processing these multiple data types in time alignment?
Sure, I think I understand what you're getting at, but the ground system, let's say, is two parts. The DataHUB, of course, and its role is to, of course, bring in PCM streams, convert that, record it, and publish it, so that you can record, visualize the data. And right now, it's supporting the Chapter 10 standard for recording. And then NetView, of course, is meant to display and aggregate that data. But all along, data is time aligned at the PCM stream level, and of course, part of the data packets coming into NetView. So allows NetView to further time align when it's playing back or playing data in a real-time environment. So they both have perhaps unique roles, but at the end is to record and display that data in a time synchronous manner. Yeah, I hope that gets at what you were driving at.
Great, and we will get back with a more detailed answer to your earlier question. I think Mark Buckley will definitely to help with more detail there. And I should just say we had a couple of requests for slides, Chris, and possibly even the pictures within the slides. I don't know if you can share them, but do you have an email address that people can contact you on?
Certainly. I think this slide deck is going to be available for download through this platform, so we can do that. And then if people can reach me directly, of course, for any other information they might want. I don't know whether we can send an email afterwards with my contact info. Not sure what's possible there.
We'll do that. I'm sure we'll send an email to the attendees with contact info if you want to contact Chris. But we'll make this downloadable. I've got another question coming here from Robert Wales. What data rates can the NVMe drive in the DataHUB?
Sure. Again, because we're using an FPGA processor and those are NVMe drives are connected directly to it, basically the full rate of the PCM stream. So the 8 channels at 50 megabits recorded to disk with no issue.
Cool. So and is this like for the products that you're now building, and that, you know, as I say, the screenware at the end there where it seemed very user friendly, like you can jump in. Is telemetry becoming easier for users? Is this now more sort of intuitive than it used to be?
We like to think so. You know, I think a lot of the older environment perhaps was a bit more complex and discrete software for discrete hardware and so on. But you know, this multidiscipline approach we're taking, we believe, really makes things quite a bit more straightforward. Using the example of the aerospace customer doing a ground test, it wasn't a significant amount of work for us to be able to take NetView to meet that environment. A case where we're taking a simple, a proprietary data stream and putting it into a standard really opened up the doors for that case. So is it getting easier? I don't know. Is it getting, is it able to be more cohesive? I think yes.
Yeah. We've got another question coming here. Is this about something that was possibly on one of the slides that somebody missed? They wanted to see the FFT plot in NetView. Is there a slide on that?
I don't have a specific slide on that, but and the data I have here, I don't know. The data that's currently loaded, it might take me a moment, is yes, an FFT is possible in NetView. I don't know that I can show that at this moment, but yes, NetView has an FFT capability.
And another one here, we've got time for probably maybe 2 or 3 more. Joel Weber has asked what input video format is supported.
An NTSC style video format. I'm assuming we're talking of the DataHUB.
Cool. Well, that's nice. Nice and straightforward. Is there, out of your range, is there a most popular product?
I'm sorry, say that again?
Out of all your products that you have, do you have one that's the most popular? Is there like a star of your range?
No, I think everything is a star.
The whole
that's right. I think some of our products might be very specifically purposed for a certain type of testing, but we're seeing a lot of popularity with our Ethernet switches, the ruggedized Ethernet switches, because they have GPS receivers and they have an FPGA processor in them, so we can do data conversion and that type of stuff. And they also have a PCM input and output capability, so they work very well as a gateway type of device. So we have an Ethernet, multiple Ethernet streams coming in. We can aggregate that data and put it in a Chapter 7 PCM format, and then bring that to the ground, and a DataHUB or a switch can then decode that. So I would say that's a popular product, and the DataHUB is certainly becoming a popular product for us.
Cool. I don't know if this is a follow-up from John Brett. He says I'm in IADS. I'd like to know who has what for my customers. I don't quite understand. Maybe it's supplementary to the previous question. Do you understand that, Chris?
Yeah, so IADS is a software similar to NetView, so I think he's yanking my chain a little bit.
Ah, I see. Okay. You said earlier as well that it's Linux and rather than Windows. Is that a new sort of new innovation for you?
For us, no. I mean, most of ours products in the past probably 8 to 10 years have really driven towards the FPGA and Linux type of environment. Some of the capabilities that brings for us is the ability to do everything in the hardware. You do that at line rates, so the faster, more powerful your FPGA is, of course, the more you can do with it. And then the Linux to set up and program. So that just gives customers the flexibility to not rely on a Windows environment for real-time testing.
Yeah, fantastic. All important. Well, I think we're just about out of time, I'm afraid. But so we'll have to wrap things up. But it's been really interesting. Thank you, Chris, for that presentation and for answering all the questions. And yeah, as I say, I think we'll make the slides available, and we'll circulate your contact details as well, Chris, if that's okay. So people can contact you direct if they need to. Okay.
Very good.
Brilliant. Okay. Well, thanks everybody. Thanks everybody for attending, and hopefully we'll see you on the next aerospace testing webinar.
Thanks everyone.
Thank you.